one of those politicians with like tons of microphones at me. Okay, so one last mic check. Can everyone hear me? Okay, great. As you can hear by the sound of my voice, I'm recovering from a nasty cold, so I'm sorry. I promise you guys, I've hit puberty. It's really confusing because of my boyish charm and looks. Okay, so welcome everyone. I'm going to talk to you today about some interview questions that we've asked, and they turned to all sorts of like interesting and cool and funny Kubernetes shenanigans. This talk was prepared by myself and by my coworker and partner in crime, Travis Lowe. Unfortunately, Travis wasn't able to make it here today, so unfortunately for you, you're stuck here with me. Wait. Another thing is that I'm using two laptops to do this presentation because for some reason I can't see my speaker notes here. So this is quite awkward. Here's my second laptop. It's going to be interesting. So what am I going to talk to you about today? So how many people here are familiar with Kubernetes? Show of hands. Awesome, that is so great. Okay, great, because the last time I gave this talk, I had like 3 hands. Wow, okay, great. So now you can also like call me on my BS. So what is Kubernetes? For those of you who are not familiar with it, so there was this saying years ago that the internet is a series of tubes. And I think that today the internet is more like a series of cubes, right? Everything that we do or every service that we're accessing today is running on Kubernetes. So if you're even like asking, I don't know, ChatGPT to generate an image for you, there is some Kubernetes magic that happens behind the scenes and some workloads are spinning up in the back and this is all, you're doing it. You're hitting enter on your ChatGPT window and things start spinning up. And because everything is focused and is built with Kubernetes, there's also a lot of like really interesting pitfalls that we can come across. So Kubernetes is also a series of YAML-induced headaches. So that's the way I like to put it. So Travis, who's not here, he sort of got me into Kubernetes. I wasn't that much into it, and the amount of YAML that I had to deal with was kind of horrible. I'm not a big fan of YAML, but this is what we have, right? Now, the origin story, completely unrelated to the previous talk or to the whole theme of the conference. This is just a slide that we put, and I'm happy that it's working well with the conference. So the origin story of this talk is that Travis and myself, we work at CrowdStrike, and we're interviewing a lot of people for our cloud security team. We're focused on building our cloud line of products, and a lot of the people that we're interviewing, we're asking a lot of Kubernetes questions. And unlike the great show of hands in this room with people who are familiar with Kubernetes, a lot of people, and that is very surprising, they are coming to an interview and they have no idea what they're getting interviewed about. So we're interviewing a lot of people. Some of them know stuff, some of them know nothing. But the questions that we ask and the answer that we're getting are really, really interesting. And this is what we're talking about today. So if you came to this talk looking for exploits, you're going to be disappointed. But I will show you some cool tricks to steal and exfiltrate data out of Kubernetes clusters only by using Kubernetes native features. So we're just abusing the system, which is my favorite thing to do. So the obligatory, who am I? So I'm the guy on the left with the weird name. I'm Amit Serper, and I've been doing security research for a while now. And I said, I know my boyish charm and good looks, it's kind of hard to tell, but I've been doing this thing for 20 years now. And every time I say I've been doing this for 20 years, I feel very, very old. And Travis, who is my coworker, and he's not here today, he kind of made me respect Kubernetes and hate YAML even more. I'm leading the security research on Linux and cloud stuff on CrowdStrike, and that's me. This is Travis, who works with me on my team. He's like my Kubernetes god. I always come to him with weird questions, and he always gives me the answers, and somehow he has the patience for me, and not many people do. So when we were making this talk, I saw this meme. Wait. And it's so true because this is my house. On the left is my Kubernetes cluster that's made out of mini PCs. On the right is the reason why my power bill is very, very high. I used to run the server up until like 2 weeks ago. It's a 15-year-old Dell that costs to run as much as an electric car. So that's my home. And this is Travis's. So this is Travis's Kubernetes setup at home. And we're doing great. Okay, so why are we here, right? So it's a bit complicated. We're here to talk about Kubernetes. Now, Kubernetes, the first time that I saw it and when I started getting into it, because my background is like low-level research, vulnerability research. Before that was malware analysis, low-level IDA, disassemblers, shellcodes, that kind of stuff. And when I saw Kubernetes, I said two things. One, this is very high level, too high level for me. It's written in Go. And the second thing that I said is, holy shit, it's so over-engineered. Like there's so many components, there's so many moving parts. You have the API server and etcd, which is the database that keeps everything in it. And you have the scheduler, which is what plans which workloads go up and down and where they go. And you have the controller manager, and you have all these stuff, right? And each one of those components have to be healthy and working in order for everything to work properly. So a failure of one of those objects, one of those resources, one of those components in that big machine that's called Kubernetes, if it fails, sometimes those failures can cascade and cause a whole lot of problems. Sometimes it can even crash your entire cluster. It can render your entire cluster, and some clusters are huge with like thousands and tens of thousands of nodes. They could all be rendered useless by simply one little misconfiguration. There's lots of dependencies between all of those resources, right? So we have, and I'll go over it for those of you that don't understand what I'm talking about, but we have pods, right? Which are the smallest unit of compute in Kubernetes. Pods depends on nodes, and nodes depends on the kubelet, and services depends on pods, and ingresses depends on services. So you have a lot of like those dependency relationships between things. We also have tons of ways of introducing security or security issues into our clusters. We have our RBAC configurations, so role-based access controls. We have service accounts. We have network policies, which are like sort of like a firewall for Kubernetes. We have the pod security context. We have secrets that we need to manage inside the cluster, like passwords and tokens and API keys and all of those things. And the dynamic nature of Kubernetes, which allows you to like scale very, very quickly, and all of those things are so codependent. And when something fails, it can be pretty critical. So as I said, let's talk about some basic terms. So just to make sure we're all on the same page. When Travis showed me this slide, I thought it's like the Death Star or something, but it's actually a can of paint, right? So let's talk about some quick overview of Kubernetes. So what is Kubernetes, right? Kubernetes is just an orchestration platform. Kubernetes is made solely for the purpose of starting, stopping, managing, and building and running containers across a lot of computers in all sorts of ways. It's the industry standard for container orchestration. As I said, pretty much with every big service you're using today on the internet, there's a Kubernetes thing behind it. When you're using ChatGPT, you're hitting enter, something spins up in the background. The whole point of Kubernetes is to manage things at scale. So you could have like a small 2-node cluster made out of 2 mini PCs at your house like I do, or you could have like 10,000 nodes on AWS running all sorts of containers. Kubernetes can do it all. Let's talk about our core components for a second. So in Kubernetes, we have 2 planes. We have the control plane, which is the backend. This is what runs everything. This is the API server that you talk to when you're configuring things. etcd, which is the database that saves everything in it. The scheduler that makes sure, okay, so this workload should be spun up on this node because it has a GPU that's required by this workload. Or this workload should spin up on this machine, which has a more beefy connection to the internet because it needs more bandwidth. And this workload should spin up on that node because it has more RAM, right? So kind of getting what you kind of understanding where I'm going there. And we have the worker nodes. So worker nodes are simply computers that are running your workloads. So a worker node could be a physical computer, it could be a virtual machine, it could be an EC2 instance on AWS, anything that can run Linux and run containers can be a node, assuming that you're installing all of the Kubernetes stuff on it. Every worker node has something that's called a kubelet. A kubelet is sort of, it's basically the agent for Kubernetes. So the kubelet is running on a node, and this is what makes this computer a node. This is what makes it a part of the Kubernetes setup. We have our basic units, which a pod, so as I said, it's the most basic, smaller unit of compute. And we have deployments, which is when we want to define a workload. We're calling it a deployment. Okay, now we're deploying this app into our cluster. And we have services. Services is what we often like expose, or how we manage what we expose to our deployment. So if we have a web server that's running a WordPress blog, because this is always the example, so we have a service that is tied to that deployment. The benefits of Kubernetes, it's easy to manage, and if everyone here, again, how many of you that are actually using Kubernetes think it's easy to manage? Okay, so we had like, I don't know, 30 hands, and now we have like one guy who says it's easy. This is my entire point. Thank you. It has self-healing capabilities, so in often cases when something breaks, Kubernetes can sort of figure it out itself. For example, let's say you have a workload that's running on a node and something happened to this node and it crashed. The scheduler will know to say, this node is not working anymore. This workload, this deployment is now down. Let's spin it up in a different node. We can do horizontal scaling. Oh my God, my website, my WordPress blog has so many hits on it right now. I got to spin up another container with another web server or another database or something so that I could handle this traffic better. In the olden days, that was very complicated. In the age of Kubernetes, it's like very easy. It just happens if you're configuring it that way. We have load balancing. So what if we have a lot of servers or a lot of pods that are running a server, and we have lots of traffic, and we want to distribute this traffic sort of evenly or in a certain logic so that one node won't be overloaded? Kubernetes gives us load balancing for that. So the common use cases for Kubernetes are obviously if we're using microservices, like if you're building an application with like microservices, so each team can work on their own microservice and deploy it separately. Cloud native, so if you're building a cloud native application, everything again is run by Kubernetes somehow. CI/CD pipelines are really cool because you can push in a new version to Git, your CI/CD pipeline picks it up, turns it into a container, pushes it into your repository, Kubernetes does a rollout, and it updates the deployment, the workload that you just pushed. But there is more to that. So all of those things are part of the objects. It's the rest of the objects that I'm not going to talk about, but all of these exist in Kubernetes. So as I said, Kubernetes is very complicated, very over-engineered, and in my opinion, not the easiest thing to learn as someone who started to mess around with it not that long ago. But let's talk about what we care about today. And this is the part where I'm looking at my notes. So we're going to talk about ways to extract information out of a cluster by abusing the features of Kubernetes. And I'm also going to show you one of the interview questions that we've asked. And I'm going to show you how you can like cause a lot of chaos in a cluster fairly easily, assuming you have the permissions to do that. And this is one of the interview questions that we're asking, and this is where we're getting a lot of interesting answers, but we never got the answer that I'm going to show you. But let's go back to talk about some more Kubernetes basic stuff. This is so difficult with the notes on a separate computer. Okay, so let's start from. Can you see the mouse pointer? Yeah. Okay. Let's start to look at this from the right side. Okay, so we have an internet client accessing a service. Again, let's use the WordPress blog as an example, right? So we have a person that's coming through the internet, and if that person hits the load balancer first, that load balancer routes you to a service, and that service routes you to the actual deployment. Now, what we have here, is a deployment. The deployment has a pod, which, as I said, smallest unit of compute. Inside the pod, we have a container. All of that lives in a namespace. A namespace is just, it's not like a Linux namespace. It's just like a thing where you can say, okay, I am putting all of my deployments in this namespace, or I am giving someone permission to deploy things in this namespace. But having something in a namespace on its own doesn't mean that things from this namespace can talk to other namespaces. So it's not a Linux namespace. A Kubernetes namespace is just like more of like a drawer, an organizational thing you can put stuff in. Also, a pod can have multiple containers. So usually people think of a pod as a container. This is a mistake. A pod can have multiple containers. A good example for why you want to have multiple containers in a single pod is because all of these containers inside that pod, they're going to share the same Linux namespaces. So this is a bit confusing. We're not talking about now within the context of multiple containers inside a pod. We're not talking about a Kubernetes namespace, but a Linux namespace. I can give you an example for it. Let's say that you're at home and you want to use BitTorrent to download your favorite Linux distribution. Because this is what you download with BitTorrent, of course. But you want to be careful with where you download your Linux distributions. You don't want to do it from your home IP, because you don't want people to know that you're using Arch, by the way. So I use Arch, by the way. So the best way to do that would be to have a pod that has the BitTorrent client and another pod that that connects to a remote VPN. Could be any VPN you want, or any VPN that's being shielded over on YouTube. And just by virtue of having those containers in the same pod, they will share the namespace, and your pod with your BitTorrent client will then use the VPN to download your Arch ISO. So this is like a small example for why you want to use multiple containers. Now, let's go back to how things work, right? So as I said, we have the control plane all the way on the left. Control plane is what controls everything. The control plane talks to kubelet, which is a piece of software written in Go, that sits as sort of like an agent on your node. Again, a node is a computer, a server. The kubelet is what is actually orchestrating all of the containers and the container runtime on that host, and that's what manages things. We can have deployments across in the same namespace, but across different nodes. So you can have the same deployment that has the same pods just running across different nodes which are on different computers on the same namespace. And why would you want to do that? So how many of you know what a replica is? Great. So for those of you that don't know what a replica is, you can say, I want to have a service, a WordPress blog, and I want it to be, I want to have 3 replicas of it, meaning I'll have 3 pods running. In case one falls, or in case one gets too busy with the load balancer or whatever, you'll have another 2 of them. Now, because you have, let's say in my home cluster, I have 2 nodes, so it'll be divided something like that. So you'll have like one node that will have 1 pod, and you have the other node that will have these 2 pods. These 3 pods are all part of the same deployment, and they're in the same namespace. So a namespace can cross nodes. Another thing that we have in Kubernetes is our RBAC. So we have a service account, which is the who. We have the role, which is what can you do, and we have the role binding, which says, okay, this guy can do those things. Let's talk about secrets. And now I'm going to show you something. So with secrets, it's kind of interesting. By default, Kubernetes encrypts secrets with base 64. So let's say that you want to keep some secret. Come on, it's encryption. It's not funny. Let's say that your deployment has some secrets that it needs to work with, that it needs to pull from Kubernetes. You can define those secrets. You can add them into Kubernetes. Kubernetes then saves them in base 64 format, and that's how it accesses it. Obviously, base 64 is not encryption. It's clear text by any definition, and unless you have a really good reason to keep it in plain text /base64 encrypted, you shouldn't do that. There are ways around it. I'm not gonna talk about it now. But this is just to show you how easy it is to decrypt base64 secrets. Again, if you're a Kubernetes user, you probably know that. If you're not, you know that now. Next slide. Another thing that we have in Kubernetes are config maps. Now, config maps are basically just configuration files. Let's just equate them to configuration files for the sake of discussion. And you can put these configuration files also inside Kubernetes. And you can say, okay, I want this deployment to use this config map. Because if you have a deployment that's spread across many nodes and you want to change something in the configuration, you only have one place to change it. And that's the config map that's tied to all of those deployments. A config map, obviously, like a config file, can contain secrets or other important things. So a config map is also important. And the reason that and this is all going to tie back together. Now, here's the thing about Kubernetes security and visibility, and Kubernetes security and visibility. It's really complicated. As someone that works for a security company that makes a security product for Kubernetes, because it's so over-engineered, because you have a billion things a billion ways of achieving the same goal, getting visibility is kind of hard because you have the Kubernetes audit log that shows certain things but doesn't show other things. And you have all sorts of ways to get information out of a cluster, but it's not a single way. So you have, and I'll talk about it, you have like 3, 4, 5 different ways of getting information about what's currently running, what's happening behind the scenes, what's happening when you're starting a workload, what's happening when you're stopping a workload, and those things don't get piped into the same place. There's no one central log where everything gets poured out to. Sorry. There's so many objects that we care about, right? So there was this gigantic list of all of the things we want to monitor, and as I said, it doesn't really pour out to the same log, so it makes visibility very difficult. Now, the runtime side, which is what's running the workloads, and the control plane are two different things. Your runtime could be CRI-O, it could be Docker, it could be whatever. You can spin up virtual machines. Your control plane is a different thing. Your control plane is just what talks to the kubelet and tells it what to do, or what's the database that keeps all this stuff. But the control plane is not what's running the workload. As I said before with my secret example, the clusters can hold many secrets in them. So that's another thing to worry about, and you want to have visibility to. Clusters can also pave the way if you have a service or an ingress that's insecure to more critical parts of your network or your cloud environment. So, for example, if you have some publicly accessible WordPress blog in your VPC on AWS, and there's a vulnerability in that WordPress, and we all know that WordPress is like the most secure platform in the world, and there's no vulnerabilities to that ever. A vulnerability from WordPress, and it's kind of funny because when we look at like Kubernetes Kubernetes hacks, it often starts from a WordPress deployment that was insecure, and then there's a crypto miner at the end of it that's running on the. It's always a crypto miner. It's kind of boring, but what if this node, this Kubernetes node, is part of a bigger VPC in your cloud network, and it's insecure, and an attacker is in there? That attacker can now access portions of your network that they weren't supposed to access, right? So this is also something that you want to gain visibility to. Another thing about Kubernetes, and this is something that comes across a lot at interviews, and we're going to touch this thing too, is that all the attacks are relevant again. So if you are now, as an attacker, you land a shell on that WordPress pod, you want to say, okay, well, let's see what's around me. What are you going to do? You're going to scan the net, right? You're going to scan the network. You're going to scan a /16, super loud. Don't do that. But again, mass port scans are now relevant again, as if it's like 1999. Security products don't always provide the best visibility. So as I said, there's a few Kubernetes security products now. Every one of them lacks something. None of them gives you like the holistic picture of what's actually happening on the cluster. just because things are so complicated. Now we can actually begin to talk about things. Okay, so let's say that you all are evil hackers and you have cluster access and sufficient privileges, which is often the case. You would think that if someone runs a WordPress blog, this whole thing runs under a very restricted service account. No, in most cases it runs with admin privileges. Excuse me. So you have cluster access, you have sufficient privileges. How would you keep the cluster from running and recovering broken or new pods? Because we are now at a point as evil hackers where we just want to destroy everything. We've siphoned some data out and we want to burn the whole thing down to the ground because we don't want the cluster admins to figure out what happened. Sorry. To figure out what happened and to figure out how to deploy like all sorts of defensive tools or how to deploy things that will allow the administrator to know what happened. So how can we do that? So I would like to welcome you all to a game of reverse DevOps Jenga. And just as it is in real life, it is always DNS. So let's talk about DNS and Kubernetes, what I like to call a complicated hate story. In Kubernetes, we have something that's called core DNS. Core DNS is basically a DNS server that lives and serves inside the cluster. And the cool thing about it is that it allows developers, when they're running cloud/Kubernetes native apps, it allows you to not use IP addresses. So if you use like microservices, or if you want to, let's say that you're the front end development team and you want to access the database, so you don't need to know the address of the database because Kubernetes is kind enough to give you a very easy DNS hostname. And usually the pattern is this. So it's the service name dot the namespace name dot svc dot cluster dot local, and that will point you to the address inside the cluster. So very easy. So that means for you as a developer, super nice. You don't need to know IP addresses. There's always this one host name you need to know. But for you, for an attacker, like that makes DNS the weak point because if I turn DNS off, everything goes to shit. So let's talk about that for a second, right? So let's talk about the DNS resolution flow. So a pod makes a DNS query to my service. That query goes to a pod that runs in the kube-system namespace, and that is called core DNS. Core DNS then checks the internal record, right? It doesn't go out recursively. It looks inside the records of Kubernetes, and it returns the corresponding cluster IP address. So that's how things work. Now, let's take down DNS. So what happens if we take down DNS, right? As attackers, we can say, okay, I want to kill core DNS. I don't want the core DNS pod to work. So if you do that, new DNS queries from pods will fail because their DNS server is missing. It's down, right? Existing connections remain unaffected because they're already cached in. Connections is already up. You're already communicating with an IP address. You don't need that. So that still works. DNS resolution timeouts will occur for new requests. So if something new needs to get resolved, obviously that's not going to work. That's going to fail. And applications start to behave really unexpectedly. They crash, they hang, they give you all sorts of weird errors. Things are starting to fail. Considering that a DNS query in Kubernetes, the default timeout is 5 seconds, it's also going to introduce slowness. Pods will try DNS queries again and again and again and again and again and again, which causes things to hang more. Applications will start showing errors like cannot resolve host. Okay, you get where we're going. It's annoying, but it's still not a complete disaster because things are still up. Things are still working. Some requests can still make it. New requests can't. Now I have a question for you. Last time I gave this talk with Travis, we gave out small, shitty plastic trophies to the audience. I don't have them here, so you'll get claps. So this is what I can offer you today. I can offer you a handshake after if you want. So, audience question. What if the admin wants to start a new pod with a new container? So we just killed DNS. There's no DNS, what I told you the last time. But now an admin wants to spin up this pod that has some tools on it to see what happens. Will this pod start or will it fail? Huh?
I'm
You're saying fail.
Yeah.
You're saying fail. Anyone else wants to?
Fail.
Fail. Okay, anyone else?
Is it say start?
Huh?
I'll say start.
Okay.
Is it possible that pod will start, but the service, you won't be able to like resolve the sort of assign a like cluster IP to the service?
Okay. So, those of you who say that the pod is going to fail, you're not getting claps, you're not getting handshakes. I'm sorry. My apologies. Those of you that say that it's going to start, you're right. And that happens because, let me go over this slide and you'll figure it out, you'll understand. Okay, so the kubelets DNS role, right? It acts as a local DNS configurator for pods on the node. When we're starting a pod, kubelet actually tells the node to pull the container image from whatever repository you're accessing, so Docker Hub or your internal repository or whatever, right? This request gets resolved by the host and not by the kubelet. So that's why it's going to succeed. So the pod is going to spin up, but once it spins up, nothing is going to work inside it, right? So good on you, sir. You get a handshake. I wish I could offer you. Yeah, I can't do that. You can give me your email address, and I'll send you something that's totally not malware. I swear.
I get enough of that already.
Oh, great. Okay, share some with me. Okay, so let's talk about the role, right? So Kubernetes, as I said, it acts as a local DNS configurator for the pods on the nodes, and it manages /etc/resolve-conf for each pod, right? So each container that's a part of a node has its own /etc/resolve.conf, which is in Linux. It's the file that has all of the DNS configuration, and that gets injected by kubelet into these pods, which is why things fail only inside the pod and not outside of it. I also just realized that there's children in the room.
That's right.
So I should tone it down. That never happened to me. Yeah, my talks usually have more profanity in them, so you guys are in luck. Okay, I covered that, and I covered everything. Okay, yeah. So node level DNS cache, right? So node level DNS cache is optional. We can have kubelet manage it, but it's optional by default. It's not how it works, which is why those pods are going to spin up. All of that DNS magic runs as a daemon set, which means every node that joins the cluster gets it. So every node that joins a cluster, kubelet pushes the DNS configuration into it. Why do we do that? It reduces DNS latency inside the cluster, and it provides DNS caching on the node level. And as I said in the beginning, a Kubernetes node is not resolving DNS queries through core DNS. It will be the kubelet process that will try to resolve DNS using the node system DNS server and not the cluster's DNS. Okay, so we've done that, right? So as I said, things are still running. They're kind of wonky. They're still running. How can we still destroy things? Again, we want nothing to work. So what we can do, and again, no one gave this answer in an interview. What we can do is we can patch that daemon set, right? I said there's a daemon set that runs on every node that gives you DNS. So we can patch that daemon set to say, okay, I want you to only provide DNS service to nodes that have a certain label on them. So we're doing this thing, like the kubectl patch daemon set core DNS -n, which means namespace kube system. And what we're changing is we're pushing this spec and we're putting in a node selector that says you're only going to provide service to nodes that have a label that's called non-existent and it's set to true. That non-existent could mean anything, just a string that I selected. So now none of our nodes have this label that's called non-existent equals true, right? So this will cause DNS to get evicted from these nodes. So there won't be a DNS pod on these nodes. Thus, you won't have core DNS across the entire cluster. Now, I thought that this was going to work. But no, because we still have old replicas, right? I asked you all what a replica is. We still have old replicas that are running. So what we need to do is to also manually patch and edit the replica. You can see it here with the arrow. We just changed that to 0 and things just stop working. And it's glorious because it's a cascading failure. So if you have like a cluster with tons of workload, when things are starting to fail with this, sort of like reminds me like the last scene in Fight Club where like everything explodes and the buildings collapse, because that's sort of like what it feels. You're starting to see like tons of failures in the logs, and it's like failure after failure after failure. Then nothing works. Then there's no logging anymore. It's amazing. But as you can see, this is me spinning up a pod. I call it test pod. The image that I pulled was BusyBox, just to have like basic Linux stuff. And I started trying to resolve things across the cluster. And you can see I can't have DNS. I'm getting connection refused to my core DNS service inside the cluster. DNS has failed. Nothing is working. How can we prevent that? So RBAC hygiene, super important, right? Which user can do what? Your deployment with your WordPress blog. Why does it have all the permissions in the world to do anything? I swear, most of the Kubernetes setups are like that. My home Kubernetes setup is like that. By default, there's a super powerful user. It can do anything. I understand if you're doing it like, for a project to learn how Kubernetes work, but if you're in a production environment, this is super, super duper, duper, duper bad. And this is how you get crypto miners or worse inside your network. Another thing you can do, and I'm going to talk about that and the rest of the presentation, is to put a mutating webhook. And does anybody know what a webhook or a mutating or a validating webhook is in Kubernetes? Oh, great. You're going to learn some cool things now. Okay, great. So I'm going to talk about that in a second. So that webhook is going to monitor those things, and will give you a way to handle it, and I'll show it in a second. So good monitoring is the bottom line. You got to know what's going on in your cluster, just because of how over-engineered it is. Now let's talk about how we can. Let me find the notes here in my other laptop. God damn it. There we go. Now we're going to talk about how we can exfiltrate data from a cluster. So ruining things is fun. Exfiltrating data is even funner. So let's talk about admission webhooks. So in Kubernetes, we have two kinds of admission control webhooks. One is a mutating admission webhook, and one is a validating admission webhook. A validating admission webhook is something that acts like a judge and says, this is allowed or this is not allowed. That's it. A mutating admission webhook can take something, so you can say, okay, I am going to add a secret to my Kubernetes cluster, and I'm going to save it in base64. That mutating admission webhook can intercept this request and say, no, we're not saving this as base64. We're saving this in a vault, and we're putting it in a way where it's not in clear text, right? So these are webhooks. Now, let's talk about what we can do here. Sorry, it's so complicated to do this with two laptops. Okay, I said that. Now, as I said, webhooks, they intercept requests. So this is the flow, right? So someone sends a request to the API server to say, okay, I want to add a secret. I want to add a config map. I want to add something. You do your authn, authz, so authentication or authorization, and then you get to the webhook. The webhook picks up the mutating admission, sorry. The mutating admission picks up that webhook with that request that has, oh, I want to add that secret. Now, if there is a webhook and that webhook can see all of the requests, that means that an attacker with sufficient privileges can also add their own webhooks. Are you getting to where I'm going with this? So, let's talk about the flow of admission webhooks, and I'll show you a demo. Right? So this is the flow. I am dreading this because I have my notes here and I need to show you this. So, okay, let's do this. In number one, a developer makes a request to create new secrets. Then the webhook receives that request and validates the secrets. Then number three, Nginx, we have an Nginx server that's hosting the webhook inside the cluster. Nginx receives that request, runs our webhook, runs our admission, and says, okay, this is valid or this is invalid, right? The request, and that now we're in number four, the request gets either allowed or denied. If it is allowed, meaning return true, it gets persisted into the Kubernetes database. If it's disallowed, if it's illegal, right, the user gets a 403 error and it's denied. Did it. So, let me show you an example for a validating webhook. So what we care about is actually what the big green text. So this is how we define a webhook. We have in the URL, you can see admission.jellyparks.com. This is the address of our webhook, where it is. And we are also telling the webhook, listen, this is what we care about. We care about those resources. We care about pods and config maps and secrets, meaning fire up every time something is being done to any of those resources. A pod, a config map, or a secret. How am I doing on time, by the way? Okay. So now, let me show you a demo. Oh, the demo is here. Ha 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 ha. Not this one, not this one. This is the demo. Okay, let's do it. Okay, so this is our validating webhook. This is the code for it. Super simple, written in Python. We have our app route, which is /validate, so jellyparks, blah, 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 /validate. And what we're doing is we're taking from the request that's being sent to us by Kubernetes, we're taking the UID and the kind that's in the YAML, right? We are then looking for the string that has the secrets in it, and then we're going to allow it. That's pretty much it. Now, I want to show you what happens. So, we're starting the admission webhook server. And this is the webhook. This is the address, as I said before. And we're monitoring the operation create on these resources, pod, secrets, and config maps. So every time we're creating a pod, a secret, or a config map, our webhook is going to grab that. Now let's run it. So here, we're just going to delete the secret that we just added, and we're going to add it again. So that's what the... It's there on the bottom. It's kind of hard to see. Why is it? Go away, bar. Go away. There we go. So we just created the secret. Let's go to the other window with our webhook, and we can see that our webhook, you see, grabbed our secrets. So here's the password, here's the username. If this is attacker control, and this can be totally outside of your cluster or inside of your cluster, but this thing, if an attacker puts in a webhook inside your cluster, this sort of stuff can happen. We're exfiltrating stuff out of the cluster, and we're using Kubernetes native features. So this is what we've just extracted with a webhook. Okay. Wow, this is so difficult. Okay, let's do present. Okay, how can we prevent it? Again, healthy RBAC. So make sure that only the permissions that are required are available to the workload that you're running. A WordPress deployment shouldn't be able to, manipulate secrets or add webhooks. Also, if you're a cluster admin, how often do you change your webhooks? Do you do that on a regular basis? Do you add and remove a bunch of webhooks? Most people don't. So monitor the webhooks on your cluster. It's super important. If you have a Kubernetes security product of some sort, see if you can have a detection for new webhooks. So that, again, depends on the Kubernetes security product that you're using. Another big question is, do cyclists have to stop at stop signs? The answer is yes. The answer is yes. If you're a cyclist, you gotta stop at a stop sign. I almost got ran over one day. Not fun. Now, another thing. As I said before in the example that I gave, all the attacks are new again. So if you're an attacker and you just dropped into a shell on a pod, you want to know what's around you, you're just gonna scan a /16 like it's 1999. That is really bad, right? Because it's super noisy, very easy to detect. And, suddenly your admins, your security people start seeing lots of scanning activity and packets from your WordPress blogs. Everybody's going to know that your WordPress blog has been popped. And also, you're scanning a /16 and you're hoping to get information for your entire cluster. So you're sending so many packets just to get so little responses, right? There has to be a better way. So let's talk about that. A lot of people in Kubernetes are using all sorts of services for visibility and management. So how many of you Kubernetes users are using Istio or kubectl or Argo? Argo is a real big one. How many of you are using Argo? Yeah, I use Argo too. Argo is awesome. How many of you are using those services in conjunction with something like Grafana to have like nice graphs? I expected more of you, okay? So what I'm going to show you now is how you can use this. Let me pull up my notes here. How you can use exposed API, exposed API endpoints on your cluster to do all of this to get a complete picture of your cluster, including everything, IP addresses and everything, with one single request. This is super cool and often it's not being taken seriously enough, right? So let's go back to the demo video, and I'm almost done. So what I'm going to show you now is we have this pod that we're going to pull, right? In this pod, the only thing that it's doing, it's running this app.py file, which I'm going to show you in a second. So let's apply this file to our cluster. We created this pod. We can see that it's running. Initializing. Okay. Now, how many of you are using kubectl? You, sir. And anyone else? Okay, cool. So kubectl is this tool that you can run on your cluster to help you understand how much money it costs you to run your cluster. Because if you're using EKS or any one of those services, it can be very expensive, and you want to always optimize your costs, right? But kubectl exposes a metrics endpoint for Grafana to be able to so the Grafana would be able to show you a nice graph of what you have. Again, if those endpoints are not properly segmented and configured, because as I said, just the fact that something is in a separate namespace doesn't mean that you can't access it. Because Kubernetes namespaces are just squares on a diagram. They mean nothing. So if you are not careful enough on which endpoints are being exposed and what's open out there, you can do something like this. So we're only going to send one request to this URL right here, that's what it's called in our cluster. So kubectl cost analyzer .kubectl.svc.cluster.local. Remember, I gave that example before with the internal DNS inside the cluster. So we're going to send one request to this endpoint that knows everything about our cluster, and we're just going to format it nicely in a table. That's all this does, right? We're going to put it in a nice table. Let me fast forward a little bit. So that's what that app that we loaded is doing. So now let's look at the logs, and boom, you can see your entire cluster with one request. No need to scan. I'm almost done. No need to scan. No need to scan /16s. No need to make a lot of noise in the network. You just abuse that endpoint that should not be exposed to anything else. And look, here is our cluster. The namespaces on the left, the names of the pods in the middle, right? The IPs on the right side, and that's it. So I just showed you how you can abuse Kubernetes with one single packet. So how can we avoid that? Network policies, super important. Think of network policies as a firewall for Kubernetes. So if you have monitoring infrastructure on your cluster, it's super duper duper important that it's firewalled the right way with a network policy, so that only what's supposed to touch this endpoint can touch it, and your WordPress blog pod shouldn't, because why? And also, a very critical question that you need to ask yourself in your organization: who manages the network policies in your organization? Is it the app owners themselves? Is it the security team? Is it the Kubernetes team? Sometimes in organizations, and we've seen it, those teams are like completely separate and they don't know anything. So you have your Kubernetes team and they say, oh yeah, we're just going to give you a namespace, do whatever you want inside this namespace. But they don't take, care of other namespaces. They don't take care of network policies. So everything is just open. So again, segmentation and proper hygiene in a cluster, super duper duper important in those cases. Any questions? And please remember to rate us 5 stars. I'm done. Thank you. Any questions? Great. Thank you, guys. Oh, yeah. You, sir.
I was going to ask, can Core DNS be externally hosted at all?
I think you want to
Yeah.
come closer?